Number 4. So the question reads, find the average rate of change of the function over the given interval. Compare this average rate of change with the instantaneous rates of change at the end points of the interval. Okay. So to find the average rate of change of a function, it's basically the equivalent of finding the slope of the function between those 2 points. Okay. So the slope of the line of the function. Okay. So the I'm going to call it AROC for average rate of change. Can be defined as f of y2 minus f. Sorry, I should make the interval. So f of b minus f of a divided by b minus a along interval a, b, and f of x. Okay. So this is how you find the average rate of change between 2 points, right? So you take the function values at the 2 points and divide it by the interval, the difference of the interval. So the instantaneous rate of change is found by either taking the limit of our fundamental theorem of calculus, or we can find a derivative and we can plug it in. We can plug that interval or that point into our derivative. And the difference between the average rate of change and instantaneous rate of change is that the instantaneous rate of change measures the rate of change at a singular point of our function, while the average rate of change measures the rate of change over 2 points. Okay. And so this question is asking us to find the AROC of this function over this interval, while it's to compare it to the instantaneous rate of change at the endpoints of this interval. Okay. So let's calculate the AROC first. Okay. Alright, so alright, we know that average rate of change, I'm just going to write A here, is going to be f of 2.1 minus f of 2 over 2.1 minus 2. Okay, so we have 5 times 2.1 squared minus 2 minus 5 times 2 squared plus 2. Okay. And that is divided by 0.1. We get 2.05 and divide by 0.1. I'm just following the junior tutor solutions here. If you want, you guys can pause the video and calculate it yourself to see that these numbers are actually in fact true. And this is simplified to the average rate of change of 20.5 units. Okay. So that's the average rate of change. So now we're going to calculate the instantaneous rate of change. Okay. So first of all, we're going to find our derivative of f of t. So f prime of t is equal to, so we use the power rule here, so it's going to be 10t minus 2. 2 is just 0. So then this is our derivative. So we're going to calculate f prime of 2.1 and f prime of 2. Okay. F prime of 2.1 is 21. And f prime of 2 is 20. Okay, so you see here that the average rate of change between 2.1 and 2 is the halfway point between 21 and 20, which should make sense given that it's the average rate of change between these 2 intervals, and we calculated instantaneous rate of change between the endpoints of those 2 intervals. Okay, so that's basically it. And it should also make sense in, I guess, graphically speaking, because if you look at our instantaneous rate of change from 2.1 to 2, it increases by 1. So our average rate of change should be around the average of these 2 points. Okay? So this solution is correct. Okay?